right, so we're going to do an example where we're actually using the distance formula. I have 2 points. R is 2, 3, and S is 4, -1, and we want to find the length of RS, which means we need to use the distance formula. Okay, notice I didn't put a bar over the top of RS, which means I'm looking for length. Okay. I'm going to draw the diagram in the left-hand side. You do not need to have the diagram. I just like to see it so that I can see where my points are. Okay, so I have my diagram. Every time that I'm trying to find a distance, I rewrite the distance formula, just because this is going to get us better and better at writing the distance formula. It's also going to keep on reminding us of the distance formula so that you can see it over and over again in your notes when you need it, okay? So I'm going to write the distance formula. Distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay. All right. So before I get started, I'm going to label my R and my S. I'm going to label R x1, comma y1, and my S x2, comma y2. Now, you might ask, does it matter, Ms. Miller, if I call R x1 and x2? I mean, x1 and y1 or x2 and y2? No, it doesn't matter. Absolutely not. One of them is an endpoint. You will get the same answer regardless of which direction you put those numbers in. Okay, so we're going to start by plugging these things in. So I'm going to keep that square root sign, and I'm going to plug it in. So x2 is 4. X1 is 2. Square that. Plus y2 is -1. y1 is 3. Square that. Okay, so now I've got my distance formula with the numbers plugged in. Okay, again, if you have any questions, please ask them. All right, so now we've got to follow the order of operations. In distance formula, the order of operations is 1, do stuff inside the parentheses, just like in normal order of operations. So I'm going to start there. So 4 minus 2 is 2, and I've got that squared on the outside, plus -1 minus 3 is -4 squared. I've got the square root sign that stays. Okay. Step 2 is do the exponents, just like it is in regular order of operations. So step number 2 is do the exponents. 2 to the second power is 4. -4 to the second power is 16. I've got an addition sign in between. The next step is I need to do the addition that's inside. Okay, now this is the step that a lot of people get confused on, don't realize, and that's because there's a little hidden set of parentheses in here. In fact, I'm going to use yellow. There's a hidden set of parentheses that tells me that I need to do the stuff inside the square root sign first. I can't square root it until after I've completed all of the stuff inside the square root. Okay, so 4 plus 16 is 20, and now I've got the square root of 20. Okay. And now the fourth step is obviously take the square root. Take the square root. Now there are 2 different ways that you can do this. You can either use a calculator and find the approximate square root, or you can break it down so that you can find the exact equivalent square root. So I'm going to break it down. I'm going to do 4 times 5 inside the square root, which can be separated into the square root of 4 times the square root of 5. The square root of 4 is 2. So this becomes 2 root 5. This is something you guys learned last year. If you need refreshers on it, please let me know, and we'll make sure that we put it into the entry task stuff, because honestly, it's really important. And in fact, I did do it in the entry task today, so I'm going to continue doing that as you need it. So then our answer is 2 root 5. That's the distance. If you did it as a decimal approximation, you would have gotten 4 and 472 thousandths. Of course, there are more decimals. I just rounded to the 3rd decimal place. So both of these are great answers. I like to use the radicals, but you do not have to. Okay, seen it in action. Good job.